Today we're going to multiply using arrays. Arrays are just like equal groups, except for if we have rows that go horizontal and columns that go vertical. So our first factor is telling us the rows, how many rows we have. So we have 4 times 5, or 4 rows of 5. Over here we have 3 rows, so I'd write a 3 for my first factor, and in each row we have 1, 2, 3, 4 cupcakes. So it's 3 rows of 4. The first number is the row, the second number is the column. The column goes vertically or up and down. So 3 times 4, or 3 rows of 4, is equal to 12 in this picture we have here. I'm going to continue to make multiplication sentences based on the rows and columns I have. Right here I'm going to count the rows first. When I do that, I go straight across just to make sure that I'm counting the rows. 1, 2, 3, 4. So I have 4 rows right now. I'm going to erase my lines because then I can count how many are in each row. That's also how many columns you have. So I only have to count the top row to tell me how many columns I have. 1, 2, 3, 4, 5, 6. I have 6 leaves in each row. Now, there's something called the commutative property. The commutative property is when you can switch the two factors, and they're going to equal the same exact number. So we have 6 times 4 if I just switch these two factors, and it's going to equal the exact same number. It's like flopping this on its side. We don't have to worry about this right now because whatever answer we get here, we're going to put down here at the bottom. So now I have 6 up here, and it's just like adding 6 plus 6 plus 6 plus 6 because there's 6 in each row. So I'm just going to actually just count up. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I like to put the numbers at the end of each row so then I know how many I have, and I can just keep counting up. 19, 20, 21, 22, 23, 24. I have 24 leaves altogether. And that answer is going to go for both 4 times 6 and 6 times 4. Like I said, it's just like flipping this array on its side, and then you get 6 rows of 4. Here is another example. Now we have purple flowers. First, like I said before, I'm going to count the rows. I just go straight across. 1, 2, 3, 4, 5. We have 5 rows. Now I'm going to erase my little lines and marks there because I need to count how many columns we have or how many flowers we have in each row. 1, 2, 3, 4, 5, 6. I have 6 again. So that means I'm going to keep counting or adding until I get to the end. So I have 5 rows of 6. We're going to count by 6s technically. 6, 7, 8, 9, 10, 11, 12. We know it's 12 because of the other example we had. 13, 14, 15, 16, 17, 18. 19, 20, 21, 22, 23, 24. Now I'm going to count up 6 more. 25, 26, 27, 28, 29, and 30. I have 30 flowers all together. So that looks like a 36. That's a 30. Sorry guys, using a mouse. Now the commutative property says that we can flip the two factors and still get the same product. So I'm going to flip the 5 and the 6. It's just like flipping the array on its side, and it's still going to be 30. So now you know 2 facts, and you only had to do 1 problem. One more example. Right here we have 2 rows. I'm going to put a 2 here. Now I have to count how many stars in each of the rows. I have 3 stars in each row, so I have 1, 2, 3. And then the next row I have 4, 5, 6. So 2 times 3 is equal to 6. I can flip those 2 factors around. 6 times 2 is equal to 6. Whoa, sorry. 3 times 2 is equal to 6. Let me do one more. I think I might have time. If I don't have time and the video runs out, I want you to think about it in your head. All right, I'm counting my rows. 1, 2, 3, 4. I have 4 rows. I'm going to erase my marks and count my columns, or how many in each row. 1, 2, 3, 4. This one is 4 times 4, or 4 groups of 4, or 4 rows of 4. It's all the same thing. So I'm going to count by 4s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I have 16 altogether. This one really doesn't have a commutative property because